Organic chemistry. Organic chemistry is the study of carbon and its compound. Characteristics of organic compound. Organic compounds are mostly covalent. Organic compounds are soluble in non-polar solvents. Organic compounds are non-polar solvents. The reaction in organic compound tend to be slow than the ionic reaction in inorganic compound. Organic compound burn typically in principal supply of air to create carbon dioxide and water. It terms used in organic chemistry. While the homologous theory. Homologous theory is the family of organic compounds which follow a regular structural pattern in which each member differs in its molecular formula from the CH2 group. For example, we have the alkane which have the molecular formula of CnH2n plus 2. We have the alkene, we have the formula of CnH2n. And we also have the alkyne which is CnH2n plus 1. All the family of the alkane can be calculated using this molecular formula or structural formula. For example, we have the alkane family which is the CH4, C2H6, C3H8, C4H10 and C5H12, so on and so forth. For example, let's calculate this is our methane and this is our ethane. This is our propane, and this is our butane, and this is our pentane. For example, let's calculate our ethane using this molecular formula. When you are calculating our ethane, the number of carbon, we are supposed to use the number of carbon, not number of hydrogen. So, see, this here will replace 2H2. Our end, you know that our number of carbon is 2 here, we replace this 2 here, it will not be 2 plus 2. So, C2H, 2 times 2, 4. 4 plus 2, 6. That we have our ethane. So, we can also use our structural formula, which is, when you are looking at the structural formula, you count the number of carbon. For example, if this, our ethane has 2 carbon, we are supposed to write that 2 carbon. 1, 2. 1, 2, 3. If you can observe that when you count the number of carbon, you replace it with hydrogen. You are supposed to have the number of hydrogen that it gives you here. So let's count 1, 2, 3, 4, 5, 6. That's how we got our ethane. Let's have our alkene. Alkene is gotten by removing 2 hydrogen from the alkane group. It's usually start with ethane because you cannot remove 2 hydrogen from here. If you remove 2 hydrogen from here, it would be CH2, which is its molecule, because each of this member is trying to have a formula from the CH2, but it cannot be possible. So if we try to remove 2 hydrogen from here, our ethene will be C2H4. So we can calculate this our ethene by using this formula, which is the formula for calculating ethene. For example, we have CnH2n. Our number of carbon is 2. Replace it with 2. Our number of carbon here is also 2. Replace it with 2 times 2. That be C2H. 2 times 2 not be 4. That's why I have this one. So the alkene also have the structural formula. The structural formula is also different from the alkene because the alkene have a double bond on it. It was observed that when naming compound, we make use of we count the carbon first. Let's count 1, 2, 3, 4, 5, which is our pentane, because you have 1 bond. If it's 2 bond, it will be pentane. So let's count number of. They said that the carbons are supposed to have the lowest number of like this substituent, this number are supposed to have the lowest number of carbon because you cannot name. It's a law that cannot name a compound that has highest number of carbon. So if you count from here, it will be higher. But when you count from here, it will be lower. That be when you count from here, it will be 2. That be 2. This substituent is alkyl group, which is 2 pentanes. Thank you.